Hey, this is Mr. James, and in this video we're going to be learning how to write two-column proofs with transversals and the angles that are adjacent to transversal. In the past we've done some two-column proofs, but those have largely centered around algebra and substitution and a little bit of geometry. But for these proofs we're going to use 100% geometry and maybe a little bit of algebra, but mostly geometry here. So let's just jump right in and try a few. So just like the other proofs, we have a given and what we're trying to prove. So for this first one, given m is parallel to n. Let me mark that in my diagram. All right. And we're trying to prove that angle 1 is congruent to angle 5. So let me just kind of mark those right there. I'm trying to prove that those two are congruent. Well, wait a second. They're corresponding angles, and I know that corresponding angles are always going to be congruent. So those two are kind of connected because they're corresponding angles. And that's all I need to do the proof. So let's go ahead and write that two-column proof. So remember, in the beginning of any proof, we're going to write down what we're given. M is parallel to n. That's given. And then I can skip straight to saying that angle 1 is congruent to angle 5. Why is that? Well, if you flip to your note sheet, your theorem sheet, the second side, and scroll down, here are all the different theorems that we can use in our proof. And, well, I said they were corresponding, and so this says if the lines are parallel, and they are, then those two angles are congruent. And so, since the lines are parallel, then I can say that those two angles are congruent by the corresponding angle theorem. Pretty straightforward. Right, so the first one's pretty straightforward. Let's take a look at the second one. All right, starts the same way. Given m is parallel to n. Let's mark that in the diagram. All right, and prove angle 1 is congruent to angle 5. Well, that's the same thing as before, so let's mark that. Angle 1 is congruent to angle 5, but there's a difference here. This says that you can't use corresponding angles. So I can't do the same thing as before because I can't use corresponding angles. What are we going to do? Well, we can do something a little different here. We're going to use more than just one relationship between angles. To do this, we're going to use 2 or maybe 3. So start by looking at this diagram up here and circling all the angles that are congruent to 1 and 5. Did you do it? 3 and 7 are also congruent to 1 and 5. They all have the same angle measure. And so what I can do is, instead of going straight from 1 to 5, I can say, well, 1 is congruent to 3 because they're vertical angles. And 3 is congruent to 5 because they're alternate interior angles. And then since 1 is congruent to 3, which is congruent to 5, then 1 is congruent to 5. Okay, and that's all we're going to do. Let's write our proof. Okay, remember we always start out with the parallel lines that are given. Remember, that's very important that those lines are parallel, otherwise we couldn't do any of this. Then angle 1 is congruent to angle 3, just like I said before, because those are vertical angles. Remember, right up here, vertical angles. And then I can say that angle 3 is congruent to angle 5. Okay. Again, that's because they're alternate interior. And now my last step is going to be to show that 1 is congruent to 5, that this chain all fits together. Now what do we call that? Well, if you go back to your theorem sheet, right here, if you read, it says transitive property. If A is congruent to B, and B is congruent to C, then A is congruent to C. That's kind of like what we have here. We have angle 1 is congruent to angle 3, which is congruent to angle 5. So we can shorten that and just say angle 1 is congruent to angle 5. And that's called using the transitive property. So the last step on our proof will be the transitive property. There's that. End of proof. Now I have a feeling that you can do the third one by yourself. So try and pause the video here and do it by yourself. Alright, let's see what you've done. So hopefully you should have started out with m is parallel to n. That's given. Remember, that's how we start all of our proofs. But next we have to prove that angle 3 plus angle 6 equals 180 degrees. So let's take a look at those up here. Here's angle 3 There's angle 6. Well, those look like same side interior angles. So, if we look back at our sheet here, there's same side interior angles. If the lines are parallel, then they add together to equal 180. That's exactly what we're going to do here. Okay, and so our last step is going to be that they add up to equal 180 because they're same side interior angles. Perfect. This next one and the last one on this page is kind of like the last one we just did because we need to prove that angle 3 plus angle 6 equals 180 degrees. However, it's kind of like the second one we did because we have a restriction. We can't use same side interior. Just as like in the second one, we couldn't use corresponding angles. So we're going to have to find another way around that, and maybe we'll have to use more than one step here. But let's mark our diagram and come back to the proof in a second. So let's see here. We've got that M is parallel to N, and that angle 3 plus angle 6 adds up to 180 degrees. And please don't mark these the same way, 3 and 6, because they're not congruent. Maybe put one mark on 3, another mark on 6, maybe use two different colors, but don't mark them the same way, they're not congruent. So I can't use same side interior angles. What am I going to do? Well, let's start the same way we started the last one. Let's start by writing down the angles that are congruent to 3. So 3, 1 is congruent to 3, 5 is congruent to 3, and 7 is congruent to 3. Those are all congruent the same angle measure. So what if I said, okay, well 3 is congruent to 7 because they're corresponding angles. And what if I said that 7 and 6 were supplementary because, well, that's a linear pair. Okay. And that would work. I'm not going straight from 3 to 6. I'm using 7 as kind of a bridge in between 3 and 6. I think we could do that. Let's go write the proof now. So of course you start your proof off every single time with your givens. Next, we're going to write that first step, that 3 is congruent to 7, right? And why is that? That's because they're corresponding. Okay. And next, we're going to write that 7 and 6 added together equal 180 degrees. And why is that? Well, it's because they're a linear pair. Okay, linear pair. And then, since 3 is congruent to 7, what I can do is just take this 3 and substitute it in for 7. And now I've got that angle 3 plus angle 6 is 180 degrees. Now, I wouldn't call this transitive because I'm not doing the thing up here where I'm chaining 1 to 3 to 5. But I am substituting that 3 in for the 7 to get to my final answer here. So we call that substitution property. And that ends this proof. Now that you've kind of got the fundamentals down, let's kick it up a notch. Look at the back page. We've got this crazy quadruple transversal thing going on here that's kind of hard to work with, but we're going to get through it and I'll show you some tips. Let's hop right in and try the first proof. Given M is parallel to N and P is parallel to Q. All right, so let's mark that. M is parallel to N and P is parallel to Q. Remember to use different markings to show that P and Q go together and M and N go together. And I've got to prove that angle 13 is congruent to angle 2. So angle 13 is congruent to angle 2. All right, well this is kind of hard to see. Let's talk about some tips for how to work with this big picture here. Right, so here's a bigger picture of our quadruple transversal mess. And I've got 13 and 2 marked. And so what's the relationship between 13 and 2? Well, if it's hard to see, start by maybe rotating your picture around like this. And then take another piece of paper or your hand and cover up any intersections that you're not using. So don't worry about any of this right now. Don't worry about that. And now, when we're looking at just this picture right here, we can see that, hey, 13 and 2 are on the exterior and that they're on alternate sides. So 13 and 2 are alternate exterior angles. You can use this technique anytime throughout this, this video to help you see things a little more clearly. So now that I know that 13 and 2 are linked because they are alternate exterior angles, I can go ahead and write my proof. Again, I start with the givens, and then I end with angle 13 is congruent to angle 2. Why? Because they're alternate exterior angles. Perfect. Let's take a look at the second one on the back page. Given M is parallel to N, P is parallel to Q. Okay, that's like all of them. We need to prove that 13 is congruent to angle 5. So let's go mark our diagram. So parallel, parallel, and I want to show that angle 13 is congruent to angle 5. Oh, those are kind of far apart. How am I going to do that? Well, there's no one reason that will connect them. So we're going to have to use another angle kind of as a bridge in between them. So just like on the first page, let's start circling things that are congruent to 13. Well, 11 is congruent to 13, and 11 is congruent to 5. Okay, well, why is 13 and 11 congruent? Well, those are alternate interior angles. That's what those are, alternate interior. And why is 11 congruent to 5? Those are actually corresponding angles. And if you're having trouble seeing it, I'll show you using the trick I showed you before. So again, if you're having a little trouble, kind of cover up the lines you're not using. Look at 13 and 11. See how they're on the interior of those two lines? And they're on alternate sides of that transversal? Alternate interior. To look at 11 and 5, it might be useful to rotate your picture a little bit and cover up the intersections you're not using. Okay, so just look at those two. And now we can kind of see that, hey, we can see that just on that transversal, that 11 and 5 are corresponding. They're both in the kind of bottom right corner of both of those intersections. And it makes it a little easier if you just cover up the intersections you're not looking at. All right, let's go ahead and write the proof. We always start with the givens, okay? And then we said that angle 13 was congruent to angle 11. Why was that? Oh, that's because of alternate interior. That's right. Those are alternate interior angles. And then we said that angle 11 was congruent to angle 5, and that's because they are corresponding angles. All right, and then we've got to put it all together and say that angle 13, since it's congruent to 11, and 11 is congruent to 5, that 13 is congruent to 5, and what's that called when we kind of chain them all together like that? That's the transitive property. Now you might be thinking, Mr. Janes, is that the only way to do the proof? And it's not. You can find any way you can to link together 13 and 5 to show they're congruent. You could have said that 13 is congruent to 2 because they are alternate exterior. And then you could have said that 2 is congruent to 5 because they're corresponding. And your proof doesn't have to have just 2 steps to it, 2 or 3 steps. You could have said 13 is congruent to 15 because they're vertical angles. Then 15 is congruent to 3 because they're alternate interior angles. Then you could have said that 3 is congruent to 2 because they're vertical angles again. And then 2 is congruent to 5 because they're corresponding angles. So any number of steps is fine as long as there's a logical progression from 13 to 5. Now for our last proof. If you think you can do it yourself, pause the video and try it. Otherwise, here we go. Let's start by marking the diagram. I need to show that 14 and 7 are supplementary. Again, don't mark them using the same color or the same number of arcs there to show that they're not congruent, they're supplementary. How am I going to do that, though? Well, I need somewhere in between. Well, I know that 14 and 9 are congruent because they're both alternate exterior angles. And then I know that 9 and 7 are supplementary because they are same side interior angles. So I bet I can write a proof out of that. And again, if you don't see the alternate exterior and the same side interior, make sure you're turning your paper and covering things up until you are able to see those relationships. All right, so here are my statements and reasons from above. Remember, to get what we're trying to prove at the very end, we had to substitute 14 in for 9 and use the substitution property. QED.